internet issue, so I got disconnected. I'll continue from where I left.
So, madam, how long is the presentation? How long is this?
About to end. It's about to end. Not much.
Okay.
I think there are like just a few more slides.
All right.
So basically this was where I was and it got disconnected. So these are actually quality standard that are set by ADB to ensure the import of quality products. So now, like I have been focusing more on the quality, that is where there is a slight consideration for the Solar, because the Solar is a company which is fully focused on the branding of its product. And we do not never pick and choose on the basis of prices only. In fact, we do a thorough research of our OEMs and then do our joint effort to launch them in the Pakistan market. These are our basic business focus. Our vision is to help Pakistan combat energy poverty. Our values are to conduct a truthful business in Pakistan, and the mission is to conduct a knowledge-based business. This is our country-wide presence. We have our head office in Karachi and our regional offices in Lahore and Islamabad. Some few of our accreditations, we are registered with SECP, Pakistan Engineering Council, membership certificate for KCCI, and ISO 9001 quality certified vendor also. We also are registered with ADB for net metering up to 1 megawatt projects. This is our health and safety mission statement and our certification for ISO 45001 2018. And at the Solar, it is our lifetime pledge to build and engineer solutions, the elements which keep our design and constructed projects and operations clean and clean. Moreover, our firm is more interested in educating our design engineers, and their expertise are to be flourished with time. For this, our firm have made our engineers get international certification on solar from GACS and the NEU Master Certificate, which is a UK-based certification. And this is also our third-party inspection, which we do for this as per the quality standard. So they had a very effective use of the car. This was a J-Dot factory, and this is one of our warehouse number capacitor in Lahore, which went on solar. So yeah, thank you so much.
Thank you, madam. Thank you for enlightening us on quality of the products. I think quality is one of the major while setting up the projects. And perhaps if we can get good quality products, we can also have increase in life or the guaranteed life of solar panels and reduction of the tariff. So we should look into that. And good quality products have longer life, and we should calculate that also. And perhaps the solar projects, which are guaranteed for 20 years life till their efficiency goes down by 20%, we should have at least 30 to 35 years life now, so that the tariff is, reduced, and we can promote solar energy more and more. So thank you, madam. Thank you so much. And now I'll introduce our next speaker, which is Wasim Qureshi Sahab of Kilowatt Labs. Wasim Qureshi is basically an engineer, an entrepreneur, and also an inventor. So he has introduced a number of products into the solar market, and one of them is supercapacitor or energy storage. This is an old idea, which was Wasim Qureshi's own idea. And WRL is the SEAM Research Laboratory, but he has also Kilowatt Labs registered. I think that is in USA most probably, as far as I know. So he's well known amongst our solar energy engineers and developers. So Mr. Wasim Qureshi, we request you to please enlighten us about your research and inventions. Can't hear Wasim Qureshi sir.
जनाब ये साउंड नहीं आ रही, आवाज नहीं आ रही।
अब आना शुरू हुई है
जी, अब आ रही है।
Hello, can you hear me?
Yes,
can you hear me?
Yes, now we can hear you.
Okay. Believe me, it's not me, it's Zoom. Let me realign the presentation and everything. Just need a second for that. Please stay with me. I'm just realigning everything because I restarted the whole forms. Assalamu alaikum. I hope you can see my presentation.
Yes, that's fine. It's on screen.
So, thank you very much, first of all, for Energy Update to give me an opportunity to explain a little bit about my technology, which I developed in 2013. The whole story was that we were in solar business, and that at that time there were no grid-tied policies, and we had to use solar power systems in an off-grid mode. And a lot of batteries were being used at that time, and I remember there were no fancy lithium mine even available, and we didn't had any other option other than to use lead-acid batteries. And in an environment of Dubai, where we did an installation of almost 120 off-grid solar sites, and the smallest one was 20 kilowatts, and the biggest one was 2.7 megawatts, and all of those installations were installed with lead-acid battery banks. And when the first summer hit them and batteries started failing and became the biggest pain, that was the start of supercapacitor-based energy storage system development. We as in power electronic research engineers, we thought that we will be able to develop some sort of control mechanism around the same lead acid batteries. And at one time, those control systems were much more bigger than the battery, and we were not satisfied. So we decided to go back to drawing board, and we developed something which would be non-chemical. And we found out the best possibility at that time was supercapacitors. Supercapacitors have a lot of limitations and lot of advantages, which I will explain, and how we covered that. So these are all our partner companies. Amber and Wasim is our research wing, where we develop, we do all of the R&D, and we are the largest R&D company in GCC region. Kilowatt Labs is our my partnership in United States. Kilowatt Labs Inc. was incorporated in 2013. Infusion Power Industries is our factory where we produce all of these things. BGT generators, as you know, we developed this technology. We developed some innovative solutions as well as, and the biggest solution we found for generators, diesel generators, was to save 53% diesel by embedding supercapacitor-based energy storage system with them. I'll explain that later on as well. That's also one of our company from where we are selling these energy-saving diesel generators. WRL is our sales and marketing wing, which we have now recently done a new merger with a new company, a very big industrial group, Sunny Global, has been signed with us. It's a $3 billion rupee partnership, which we signed. We are setting up a factory in Pakistan, and very soon, this will be done. And Kilowatt Labs Technologies Limited is the company we incorporate producing capacitors in Pakistan very soon. Our mission, so it's all about green, technologically advanced, sustainable planet. That's what we are looking for, and that's what we are working. That's our vision. Our mission is leading the quest to energize the world as a trusted, sustainable partner, creating valued, single-source, efficient energy solutions delivered with passion and expertise. We have been very sustainable on our vision and mission. As you know, that I am the inventor for these technologies. I have almost 18 patents relating to these technologies, and most of them are relating to power electronics. So how we started? I gave you a little bit of roadmap. In 2010, we incorporated this company where we are doing R&D research today. And we did started from telecommunication as well, but later on very quickly we moved to solar power systems. And then, as I told you, that how we entered into serious energy storage development. And in 2013, 2016, we applied for another patent, which is Centauri Energy Server, which is our power control system. We embedded with the inverter, converter, charger, and all of those things. And then in 2015, supercapacitor-based electrical vehicle system, a complete ecosystem was developed, and we introduced that to the world. In 2017, we developed a batteryless UPS. In 2018, commercial selling of Cirrus and Centauri Energy Server batteryless UPS was done, and we started selling these products around the world. And in 2019, the first microgrid commissioning was done, and this was done with United Nations project. World's largest supercapacitor factory. This is the place where I'm sitting right now as well. This factory was develop to produce supercapacitor-based energy storage systems, and we are doing that for the last 3 years now. And it's almost 5.5 acres of land and fully automated factory where we are producing our supercapacitor-based energy storage system, Centauri servers, and UPSs, and now we are entering into EV charging stations. Energy storage system, energy servers, charging stations. We have developed EV batteries as well, which can be charged within 1 minute. Battery-less UPS, because we are supercapacitors, we call battery-less UPS. Digital generator. Recently, we have launched a product lower price or low-end product range. We named it Vega. Sirius is our high-end product, and for a low-end market, we introduced a new product which is named as Vega. And we have launched another product which is open frame series, in which customer can buy the inside, the IP-related products from us, and then brand and wrap in his brand and market the product. For Pakistan, we have done a very significant open frame series deal with one of a very big inverter and solar distribution company, which is Inverex Solar. We have branded Inverex Powerwall is an open frame, biggest example of open frame series projects, and electric rickshaws as well. We have been selling these electric rickshaws. Somehow we couldn't get a breakthrough in Pakistan, but in Bangladesh, in India, in Indonesia, and other countries, we got a good breakthrough for this product. Sirius Energy Storage Systems is the world's first supercapacitor-based energy storage solution, which we introduced this product to the world in 2013, and I will explain later that what are the major features for this product. So the biggest advantage of supercapacitors is that in supercapacitors, energy is stored electrostatically, while in batteries, energy is stored electrochemically. In a battery, there is an electrolyte which stores energy. Electrons are converted into chemical ions, and they reside inside the electrolyte of a battery. So this process, is a chemical process, and it has efficiency losses and thermal losses as well. And it's with all chemical batteries, including lead acid batteries, lithium-ion batteries, nickel cadmium batteries, all type of batteries we see in the world. Most of them, actually 99.9% of them, are electrochemical batteries. So biggest advantage for supercapacitor is that we don't store energy electrochemically, we store energy electrostatically. So what are the competitive advantages? With all chemical reactions, there is a life, there is a degradation, and there is a limitation. No capacity degradation over life with supercapacitors, while and no power losses as well. When you don't degrade a battery, it means you don't need to oversize the battery to protect degradation, and this is the biggest advantage. They are safe, no risk of thermal runaway. We are safe on two levels. So one is for logistics and transportation. We are the only energy storage system of the world which can be transported by air. Actually, we have done 22 tons of cargo of supercapacitors by air on commercial flights, commercial passenger flights as well. So we are very safe as compared to lithium-ion batteries. I hope everybody knows that you cannot carry a lithium-ion battery more than 2 ampere hours with you, even if it is a power bank of this capacity. And utilization of energy is 100% depth of discharge in chemical battery. So Our new generation 4, we have launched a new set of new product as well. As we move on, we carry on research and development. We had fourth generation coming up now. Before that, in 2013, we have Gen 1. Then in 2016, we have Gen 2. In 2019, we have Gen 3. And this is a Gen 4, which is coming up. We are giving higher cell capacity. This is a prismatic cell, so it can take vibrations as well. It's more durable. As I told you, it's vibration proof. Improved connectivity, the electronic control systems and mechanisms are much more better, and it has enhanced protection, in which we have added additional protections as well. In Gen 3, we were using smaller cells, while in Gen 4 we are using 75 watt-hour cell compared to 3.1 watt-hour cells. So there were almost 1,200 cells in Gen 3, while in Gen 4 it's going to be only 60 cells. Similarly, nominal cell voltage is the same because supercapacitors cannot go more than that. Cell voltage range is the same, and the advantage is our connector. We are using much more better terminal mechanical actuated breaker is an added feature where circuit breaker can be remotely switched on and switched off. So you have much more better control over module. A USB port, Wi-Fi, CAN bus, Bluetooth, all of these communication protocols have been added. A better LCD screen has been added. So there are much more added benefits and features in our upcoming product as well. So why series? Longer cell life, supercapacitors. These are the advantages of supercapacitors. They have longer cell life. They can sustain very high temperature, -30 to +80 degrees centigrade. They have a life of 1 million charge-discharge cycles. You can do 100% depth of discharge, and that's of course safe for environment as well. So these are some of the characteristics comparison in compared to different batteries. Lithium-ion batteries have degradations up to 10 years. Lead acid 3 years. We know in some cases these are on ideal case scenarios, by the way, and best batteries available characteristics. And series is 25 years with no effect on life, degradation, and limitation on support of the capacitor. Lowest OPEX, if you consider supercapacitors, round trip efficiency is extremely high, 95 to 98% as compared to 70% lead acid batteries. By the way, in Pakistan, I have seen applications where lead acid batteries are giving only 30 to 40% round trip efficiency because they have been using them undersized batteries. You can very well imagine that a chemical battery can change its results application and usage as well. Depth of discharge is 100%. Exposure to extreme temperatures is 80 degrees centigrade. We have done a lot of outdoor installations with telco towers in Dubai, where extremely high. Actually, the temperature was the main thing for which we entered into the research and development of this product. Charge current, it's 1C to 2C for this product, but supercapacitors can take a charge current of 150C, and the same is the discharge current as well. So the biggest advantage for supercapacitors give a nameplate capacity and usable capacity. For this series, a nameplate capacity and the usable capacity stays the same. So that's the reason that for lead acid batteries, we use 5 times smaller capacity, and that even works much more better than a lead acid battery. 100 ampere hour lead acid battery, we have a formula for that we call it formula of 5. So 100 AH into 5 is 500 watt hours of supercapacity. That's the replacement of 100 ampere hour in supercapacitor. So technically, if you see that 100 ampere hour 12 volt should be 1.2 kilowatt hours, but that's the nameplate capacity of the lead acid battery. In order to put a supercapacitor battery to replace that 1.2 kilowatt hour battery, you need only 500 watt hours of supercapacitor. So this is the biggest advantage in terms of economy as well. Some people say you are very expensive. Actually, you need to size it properly to get the price economy. So we have done a lot of microgrids as well. These are some of our applications. This is microgrids. We do this. We started microgrids with the United Nations World Food Program, and that's how we entered into this business. And today, microgrid is one of our very big projects. Recently, we won a very big project for microgrids in the region, which was in Saudi Arabia. Am I allowed to say the name? Okay, it's Neom City. It's a new city, which is getting in Saudi Arabia, and Alhamdulillah, serious supercapacitor modules will be used there for microgrid applications. It's almost 500 megawatt hours. We have now developed a new type of battery. We named it Al-Amal. Al-Amal is actually the hope. The word-to-word translation is the hope. This is AC battery, AC in and AC out. Because we see a lot of people getting involved in inverters and all of those things. So we have developed a solution where you don't need to buy anything other than a battery, and which will have AC in and AC out. It can run in both, actually in 4 modes, which is off-grid mode and grid-tied mode, and it can run in off-grid hybrid and grid-tied hybrid, both modes. We have developed Al-Amal microgrid applications as well, where in a 40-foot container, we are putting 1.6 megawatt hours of AC batteries. These are some of the pictures of our microgrids, which we have installed recently. This is a picture in the United States. We have done a red car, and it's installed with the utility. Let me show you a very small video. This is a project we did in Africa, actually Somalia. I hope you saw the video. Yeah, so this is our microgrid installation in Somalia. This is a telecom case study. We won a very big, largest telecom in our part of the world, which is Etisalat. We did a proof of concept with Etisalat for a long time, and we got approved from Etisalat. And this year, Etisalat has announced that they will replace all their batteries from lead acid or lithium ion to supercapacitors. And we have won first order of 15 megawatt hours from Etisalat recently. Etisalat BTS towers, and you can see that we are installing them exactly in an outdoor installation, no cooling, nothing. and there is no air conditioning even to the battery. And we have recorded the battery temperature going to 65 degrees centigrade. So this is a telecom case study. Outdoor installation load is 4.5 kilowatt. There is a 30 kVA diesel generator. We saved 53% of their, diesel saving. 24 hours before supercapacitors were installed, diesel was running 24/7, and we reduced it for 6 hours, and then there is a big OPEX, monthly OPEX saving, actually $2,059 per month, and which ended up for $24,712 per year. And this is another, this is after, you can see that ROI became 68%, and this storage cost and all that. So payback period was only 1.5 years, and Sirius module was charging only in 35 minutes. We installed a bigger rectifier, and we did a saving, and from 24,000, the cost of OPEX was saved to $9,512. So it's a big reduction. That was the case study with which we won this order, and we convinced Onsolar to use supercapacitors in all of their applications. So Pakistan market, we have been promoting our product through our company, which is WRL Technology. We started in 2017 in Pakistan. It was really a slow start and slowly, and this year, 2020 was overwhelming, and believe me that this year that was the reason that we have decided to invest in Pakistan and to set up a factory inside Pakistan, because as of today, we have been importing inside Pakistan, which is a big load on customers' pocket for the import duties and all that. And the company decided to invest in Pakistan and to put up a factory. We have decided Faisalabad industrial zone, where 13.5 acres of land has been already acquired. A company in Kilowatt Lab Technologies Limited has been incorporated. It's going to be a public limited company, and very soon you will start. We'll start buying our machines and all those things, and the production will start. It's anticipated to be started by the 1st of January 2022. We have been doing marketing activities in Pakistan. With the exhibitions we have been participating, and all these sales highlights. We have done almost 86 million of R2P sales. We closed with ENA, which is a subsidiary of Jaffa Brothers. Inverts, as I told you, open frame series product was done, and proof of concept with 5 major telcos has been done, which is Mobilink, PTCL, Telenor, Song, and Q-Phone, and 2 RFQs have already been generated. We are expecting the sale in the 3rd and 4th quarter by 250 million Pak rupees, and expected the annual sale of 820 million Pak rupees, which is going to be hopefully by the end of this year we will have a significant market share in Pakistan as well. So these are our patents which has been already registered. Patent numbers have been awarded, and I am the owner of these patents as an inventor, and all these products has been their IP. So features of this product, I would like to now, don't want to take much of your time. We have a monitoring. Icing on the cake is that monitoring and control system is all. You can remotely monitor, you can control. It's all software-based systems. And let me just give you some successful deployments. These are a few of the pictures. We did some telecoms. This is AT&T site on the left. Salat, Malaysia. We did some microgrids around the world. our global distribution network in 43 countries now. We work through our value-added resellers around the world. We have a list of value-added resellers which can be seen on our website as well, www.kilowattlabs.com. Some of our significant customers. A testimonial by AT&T, by the way, you can see this on our website as well. AT&T, the American Telecom, is really happy with our performance, and they have given us a big, huge order for 2022 as well. And this is what we are doing in the field of energy storage. And I hope that we'll be having some significant improvements and share in Pakistan market as well. And we'll try to bring our products so that they can benefit Pakistan, people of Pakistan as well. Thank you very much. If somebody wants, I don't know what is the question and answers policy here, but I know. Irfan Sahab, you are muted.
Yes, thank you. Thank you, Wasim Qureshi Sahab. We need a dozen of Wasim Qureshis for Pakistan, actually an inventor and an entrepreneur like you. And we also need a dozen of Naeem Qureshis as well to support us promoting the renewable energy and the products which have been invented by Pakistanis. So thank you so much. There are a number of questions from the audience. But since the time is short, we would send you these questions by mail or by WhatsApp so that you can reply them satisfactorily. Thank you so much for your time and your very nice presentation. Now, our next speaker is Mr. Faiz Mohammad Bhutta. He is a trainer and a trainer of trainers, actually. He's a professional engineer with 30 years of experience and has served at technical and managerial posts of national and multinational companies. Since 2015, he has got his own consultancy and is also the CEO of Energy Training and Research Center, which is a non-profit organization registered with SECP. So I would like to request Engineer Faiz Mohammad Bhutta to give us his presentation.
Thank you, sir.
Yeah, please go ahead, Mr. Faiz.
Thank you, sir. मेरी presentation on करा दे. Yeah, I can load myself. Are you hearing me?
Yes, we can. We can hear you, but your presentation is still not on, I think.
I sent the presentation, but I have with me also. If you allow me to share the screen. Yes.
Yeah.
So, ladies and gentlemen, and Irfan Saab, thank you very much, and thanks to Energy Update providing the opportunity, and Wasim Saab ka bahut achhi presentation thi. So my presentation is a bit different. It is a skill development in renewable energy sector in Pakistan. So next. So renewable energy policy, which already has been said by one presenter, that by Irfan Saab, by 2025. 20% RE share, and by 2030, 30% RE share. Now, this ambitious target basically cannot be completed without the skilled manpower. So there is a large gap for skilled manpower in renewable energy sector. So we have to meet this. That means if we want to meet this target, we have to prepare, we have to develop the skilled manpower in renewable energy sector. Next. So what skills are required in Pakistan particularly? So skills required are what I have an experience of working for the last 12 years in solar and renewable energy. I have seen that assessment and service skills, because this is the very start of any project. If you go for any project, you have to do some assessment, some surveys. So then is the design and engineering skills, installation commissioning skills, safety and protection, which is the very weakest area in Pakistan. Our engineers are not putting much attention to the safety and protection skills. And we will be later discussing what are the problems with these skills. At the moment, I'm just listing down the skills required. Training skills, there's also need for people who can train people, and performance evaluation skills. If system is installed, okay, it has just passed 10 years. I have seen a lot of systems who has passed 10 years, and you go and see those systems, there will be rusting, there will be cabling hardening, you can see a lot of problems, the degradation, as the solar PV yield has gone down from the standards. So there is a need for performance evaluation of all those installed PV systems. Third-party verification skills, this is a very weak area. We don't have any third-party verification. That means parties who are quite qualified for this. And Pakistan Engineering Council issue consulting license, but that is a very general license for renewable energy. Next. What are the challenges? Because I, being a solar PV consultant, very large, that means a number of organizations in Pakistan. So what I have felt the challenges in solar PV plant, assessment and survey is the biggest challenge. People oversize the plants, they go and they oversize it. And I have seen many times when I go and I do my own survey, the vendors, they have that will assess to 400 kilowatt systems, but I go and assess, I say 200 kilowatt system is enough for this. There are many factors in assessment also. This is a challenge. Solar mounting design. This is, I think, a very, very key challenge in Pakistan, because of solar PV designing, mounting companies are not available. There are 1-2 companies who do not have the proper software to calculate the wind loads, the snow loads, because they are just putting the PV module. Some are putting 10 gauge, some are putting 14 gauge, and 14 gauge is very standard, while the solar PV module has increased from 330 watt to 540 watt. It is now 28 kg. And Terina Solar guy was telling now the solar PV module will become 38 kg. But the solar PV mounting design is not being changed. The gauges are not being changed. So everybody is putting a 14 gauge, you go and ask, but 14 gauge is giving a lot of sag. So we have to move to the 12 gauge, we have to move to the 10 gauge, because the solar PV module weight is increasing. Which standards to follow? Nobody knows, because we don't make standards. Standards are international standards. We have to translate them. We have built in Pakistan Engineering Council 5 codes, but I now contesting the elections for governing body of the Pakistan Engineering Council. So I have my aim to develop the solar PV code if I'm selected. Which software to use? Somebody has used an helioscope. A lot of calls come to me. Is solar PV Sys better? Is solar PV Sol better? Is helioscope better? So there is also key challenge for that. And every software is given different yield, different degradation values. Safety and protection, I already told, is the very weakest area in Pakistan, not because the engineers are not available, but solar engineers, and this is a basically electrical part. So the electrical engineers are not being hired into the solar field. So a lot of electrical power engineers are needed into the solar field, which should develop this safety and protection design standards. And also the parts, available in Pakistan, they are not adequate. They are not as per standard. There are lots are coming. So this is a weak area. This is the big challenge for us. Selection of components. So now every day the technology is changing. So my question to all the manufacturers in the last biggest conference was that you are manufacturing daily 330 to up to 640 kilowatt 40-watt solar PV module. Which module is for which application? Nobody is telling. Is the 72 cell is for commercial? Is the 60 cell watt is for domestic? So I have requested all the manufacturers, you please segment this to make easy our life also, the life of the consultants and life of the users also. That user doesn't know that as he has to put 48 cell module, 60 cell module, 72 cell modules. What is the difference between that? So selection of component. Similarly, now the mismatching has started. The PV module has a very high voltage and the inverters, they cannot bear that voltage. Now there is a change in technology is coming also in the PV inverters also, so that the matching should be done next. So what is the requirement? What kind of requirement is? So we need to have a training center, proper, well-equipped lab, site work experience, because we have to take the persons to the sites on a real-time work. They should work with hands on the real site situations, and qualified participants. This I have noticed, experienced, what students are coming to us. They are not mostly engineers. Very interesting, because we encourage engineers, women engineers to come to get training. They are coming graduates, MPs, some diploma holders. So this is the engineering. So we are not going to understand actually the solar is an engineering, solar system engineering. So engineers have to come into this field, the qualified engineers. They should come, they should design the system. So we welcome all qualified participants. So we are facing this problem because yesterday, I just tell you, a lady, a boy came to us with his mother, and mother said, please give him an admission. I said, he is not qualified. He said, for God's sake, he is my one son. So he was just a IT graduate. So we gave him the admission, but we faced a very tough time to make him understand what is the solar. So qualified participants are needed also. So we have set up this energy training center, not now. This is basically the merger of already established energy training center and pre-NAC Academy by me, which is working from 2015, and we have so far trained more than 2,500 persons in Pakistan. And this is now run by the board, because sustainability was a big issue, because we always change the companies, change different things. So we have set up now this under section 42, which is run by the board. There is a board which is running. The sustainability, question of sustainability now is over. The board is managing this, investing money, and everything is going fine. So you are welcome to this anytime. The training, we have online training, offline training, evening training, weekend training. We have a lot of trainings, and this website is given. A lot of training modules are there, and we welcome all engineers and diploma holders. The BTech is not coming into this field. This is very interesting. Next. So this is all about skill development. If there is any question, I am available to answer. So this is a very tough area which we are working, and I think we need your all support for this.
Thank you, Faiz Bhatta. This is one aspect of our industry and academia both, which you are supporting, and we are very thankful to you that you have done that most of the part, all alone, especially on the solar side, and you have a number of your students around and they have really benefited from your regular training courses. So from the audience, I don't have any question yet for you, but in case there is some later on, we will send you and get your answer for them. Thank you so much for your time and your excellent presentation and your service to the nation. Now, the next speaker is Khwaja Mansab Ali Arshad Sahab, who is Country Sales Director of Huawei Digital Power. Let's hear from him what he has to say about clean and green solar energy.
Thank you so much. Assalamu alaikum. Yes. Thank you so much. Assalamu alaikum, all the audience that I'm audible to now, for bringing me here and giving me the opportunity to talk. So I think we have already consumed too much time skipping the chapters which the population is already aware of what Huawei products are into the market. So, but I would need to emphasize on two of the elements which I personally feel pain to, that is not being given attention or priority in Pakistan. That is the innovation and technology integration when it comes to the artificial intelligence and improving the safety standards that that are key, vital, important for the photovoltaic systems, because now in the new era we are playing with higher density of the DC renewable power systems. It has increased from 1100 VDC to 1500 VDC, and within the next year we would see solutions from 3000 DC voltage as well. So I would like to share a presentation about the top trends which are lagging into the Pakistani market, and those trends are really important for the uplifting of the renewable market community in the Pakistan, as well as making renewable successful in Pakistan. So can I share my presentation, please? Hello.
Yes, we can see your presentation.
Yeah. So coming to the trends about the smart photovoltaics that would be visible by 2025, I'll start with the trends. So based upon my research, these trends are based upon the forecast from the market insights, numerous international organizations, consulting companies, industry vendors, partner surveys, and then the Huawei analysis. So all the information here is credible from different sources. After detailed modeling analysis, we are presenting it to the audience now. So the first trend is the utilization of photovoltaic plants. So integration of digital and PV technologies enables simple, intelligent, and efficient operational maintenance, production management, and asset management. So with the digital technologies like 5G, Internet of Things, cloud, machine vision, and different sensors, smart PV devices like PV modules, trackers, inverters, and the combiner boxes, they are able to communicate and integrate with each other. So by 2025, we believe that 90% of the global PV plants will be fully digitalized. The second trend that we foresee is the artificial driven upgrades. So now, some of the things are beyond the human control, and to innovate those things, to gain control over those things, a lot of efforts need to be spent upon algorithm, increasing the computing power and fetching out the data from the different PV plants. On an average, 1 gigawatt plant produces around 1 terabyte of data on an average. So that's a huge data that a human mind cannot process, that a human person cannot process on the Excel or CRV sheets. So integration of AI algorithms to compute that data and to increase the system design, optimizations, fault diagnosis, and to have a better EMS configurations among the solar and the storage, AI-driven upgrades are really important. So by 2025, 70% of the PV plants will adopt to artificial intelligence. So the third trend is the use of unmanned PV plants. More with the innovation and technology, we see now we use unmanned drones to carry out the site surveys. We have the inspection robots as well in most of the European countries. Cleaning robots for PV panel systems are getting more common these days. Then we have the machine vision. Then the smart glasses are now very popular in the European countries to reduce the O&M cost and to reduce the time of an expertise person on the site. And then we have biomorphic robotic arms for transportation, installation, and in the supply chain management as well. So this is a key factor that we would see that more than 80% of the PV plants will become unmanned in future. The fourth trend is the proactive support for power grids. So as more and more renewables are being integrated and penetrated into the power grid stations, to make that and to make the grid stable and to make the solar energy flourish, artificial intelligence and factors like smart PV inverters are really important to help us reduce. The countries who are successful in doing and achieving the low SCR is China. We have England. India is following up at a very good rate. Then we have Mexico as well. So all of this is possible by achieving accurate algorithms from the smart inverters like impedance reshaping, harmonic suppression, island protection, fast frequency modulation, and oscillation suppression. We have so many factors that we can do so. So over 5 years, the PV plants will gradually shift from grid following to grid supporting. So the fifth trend, which is very common right now also in Pakistan, is the integration of the storage with the solar on-grid solar systems. Now most of the industries are now going for solars. They have large-scale on-grid installation. Now they're facing challenges with the power factor correction. So power factor correction is really important, and you can achieve that by integrating storage with the photovoltaic systems. So the proportion of PV systems with energy storage is projected to exceed 30% by 2030. Trend is the virtual power plants. So this is very common in European countries like Germany, like Netherlands, Sweden. So now in Pakistan, with the trend of the net metering and with the very good focus on the RE policy, we see that more and more the residential people are coming to on-grid systems, net metering systems. And then we have small, medium enterprise and the commercial buildings also coming into the same race. With the technology like 5G, cloud, and blockchain management, it's very important that we now create virtual power plants. We can integrate all the power dispatch data. We can integrate all the power transaction money amounts to a cloud-based virtual power plant system, and we can massively distribute PV plants and we can manage them to VPPs. So by 2025, 80% of the residential PV systems will connect virtual power plant networks, and developed countries already working proactively on it. So the seventh trend is the active safety. When we come to this, it pains me when I don't see such kind of a specifications or the regulations into the renewable systems specifications when it comes to the Pakistan projects. Because now the DC system voltages are increasing, and most of the time we get to hear the stories like people are losing their lives, and there are fire hazardous systems. Can we mute the mic, please? Because yeah, thank you. So I'm sorry, someone's speaker is on. That's causing disturbance. Okay, so active safety is one of the foremost parameter which needs to be focused and worked upon from the regulatory side. One of the very important factors is AFCI. With the smart inverters, you can incorporate AFCI arc fault circuit interrupters, which can sense the modular level problems and arcing, and they can shut down the inverter or even the PV panels as well, as long as using optimizers. So this is really important. The human life is of the prime importance when you're working with the DC systems or the renewable systems and large scale utility projects. So the eighth trend is the higher power density, which I've been focusing on. Why the integration of cloud and AI, artificial intelligence important is that because just like Trina mentioned, they are now coming, they're increasing their cell densities. The bigger PV modules are coming into the market. So, now the systems are increasing from 1100 VDC to 1500 VDC. And within the next year, we already launched a 3000 VDC Fusion 8.0 systems on SNEC international event in China. And that will be coming to Pakistan in the next year. So all this has been done to increase the high power density of the photovoltaic system and to decrease the levelized cost of energy. And the research organizations have been able to do this by improving the material science technology, heat dissipation technologies, and engineering technologies. Uh, and also this poses a higher risk if it's not being followed by the proper safety standards and the regulations from the countrysides. So by 2025, solar energy power density will be improved over 50%. So the modular design is the trend number 9. So this is like previously people used to think about the solar EPC or the solar plants is all about integrating solar inverters, storage, or PV panels. But it's not just about integrating different components from different OEMs. It's about having a modular design which is most optimized in terms of its performance, in terms of its lower levelized cost of energy. So now more and more focus is being made on the modular design systems to foresee the future expansion goals of the industries, because people and investment companies, they mainly focus on smaller projects in the start, and once the financials start to make sense for them, they intend to go on the larger scales. So the modular design is now one of the topology that's been followed globally, and we have the string inverters for that. The central inverters are losing market trends globally. The good companies like SMA and other big brands, now they're focusing more on the string inverters and dropping down their production for central inverters. That's one of the reasons, because the modular design is the new trend into the market. And then we have optimizers is coming back to the market. We have stackable energy storages ranging from a standard size of 5 kilowatt to a multiple of as many units as you can stack. Then we have programmable controllers, and then we have a new trend of transport stations based upon the KISSOC systems. So the trend number 10, which we see with the bringing innovation from artificial technology, cloud, and other data sources, it's about the security and trustworthiness over the systems. Most of the end clients, they're more concerned about the data of their PV plants, about the components, because numerous communication methods and numerous communication protocols are used into it. So system reliability, security, safety, and resilience and privacy is key factor to everybody around the globe. And most of the countries have also their bylaws over their privacy statements and their security and safety standards when it comes to the data transactions. So this needs to be improved, and this is really important parameter, because when we talk about the digitalization, if we lack security and trustworthiness over the systems, we cannot proceed further. So these 10 trends which I've discussed, these are the vital trends we need to focus on, we need to implement as well in Pakistan, because I believe now this is the time that we start working on making the renewable energy smarter and user-friendly for the people, with less human intervention, to have better safety standards, to safeguard human safety when we are playing about 1500 VDC large-scale utility power projects, and also the redundant systems. And I know that Huawei is doing really good, and we are leading those trends when it comes to the smart PV technologies. We have integrated our inverters, our machines with artificial intelligence chipsets. So our machines are now, they are self-learning and they're self-adopting to the user experiences. We have a huge database on which we have the algorithms. So in the real-time scenario, our inverters are computing data from the PV panels and from the user experiences as well, how they're operating plants, and they are changing to their modular designs. And now Huawei has also made it possible that you can individually control each and every component of your plant. Like you can control each and individual PV panel in the field as well. And within a single click, you can have the complete analysis of your 10 gigawatt plant within 3 minutes. So this is how much we can do with bringing artificial intelligence, cloud storage, and digitalization to the systems. So this is our vision goal, and this is what Huawei is keen to do in Pakistan. Thank you so much. If you have any questions, I'm open to address this.
Yeah, thank you, Mr. Khaja Mansab Ali Arshad. Thank you for introducing us to the 10 new trends. And most of them we are waiting for, actually. In particular, we are waiting for support by solar energy to our grids, because our grids are getting unstable because of introduction of variable renewable energy like wind power and solar. And the new grid code, revised grid code, has put all the responsibility to the RE projects that they should provide grid support. And with this new trend that you have made this grid support available, Huawei has made this grid support available. I think we will be quite comfortable in introducing more and more renewable power into our network. So a wonderful thing. Thank you so much. I think there'll be very complicated questions to you later on, perhaps, and we will keep in touch with you to get all the answers.
Thank you so much. Thank you. I will be looking forward to it.
With you, I will start concluding this webinar. The first speaker, Mr. Lim Chong Boon, he also gave us very good news about the prices going down and LCOE also going down, with improvement in reliability of the panels, etc. And then his intention to start manufacturing, or intention of Trina Solar to have manufacturing units in other countries as well. What we need to do is to provide them enabling environment. And when we start talking about an enabling environment, so the policies come in. We should have to talk to the government to have such policies which would enable. I'm hearing an echo. Yeah, please. Thank you so much. So government को चाहिए कि अपनी policies थोड़ी सी revise करे ताकि जो original equipment manufacturers हैं उनके लिए यहाँ मैन्युफैक्चरिंग करना आसान हो जाए। इसके बाद हमने मरियम अरशद को सुना और मरियम अरशद साहिबा ने कार्बन फुटप्रिंट और क्वालिटी ऑफ प्रोडक्ट्स की तरफ हमारी तवज्जो दिलवाई, जो बहुत ही इम्पोर्टेंट चीज़ है। पाकिस्तान का कार्बन फुटप्रिंट तो छोटा है आजकल, इंडिया के हिसाब से अगर हम कंपेयर करें, कंपैरिजन नहीं कर सकते। हम लोग पर किलोवाट आवर ऑफ एनर्जी 40.47 kgs ऑफ कार्बन डाइऑक्साइड प्रोड्यूस करते हैं, जबकि इंडिया 1 किलोवाट आवर प्रोडक्शन के लिए 1.33 kgs ऑफ कार्बन डाइऑक्साइड प्रोड्यूस कर रही है। वहाँ कोल फायर्ड प्लांट्स बहुत सारे हैं। 60% ऑफ इंडियन एनर्जी कम्स फ्रॉम कोल फायर्ड प्लांट्स, और हमारे तो अभी स्टार्ट ही हुआ है। तो हमें इस चीज़ का भी करना चाहिए, बात करनी चाहिए कि हम इंडिया से इस सेंस में बेहतर हैं कि हमारा कार्बन फुटप्रिंट कम है और हम इसको कम ही रखना चाहते हैं। हमारे पास बहुत सारा रिन्यूएबल पोटेंशियल है और उसको यूटिलाइज करके हम अपना कार्बन फुटप्रिंट इतना ही रखना चाहते हैं जितना आजकल है। लेकिन हमें ये बात वर्ल्ड फोरम्स पे करनी चाहिए कि बाकी लोग भी, चाइना, अमेरिका, यूएसए, अपना कार्बन फुटप्रिंट कम करें, क्योंकि कार्बन डाइऑक्साइड जो ग्लोबल वार्मिंग एक मेजर वो जरूरी है। और ये असर जो है ये सारी दुनिया में जाता है। अगर अमेरिका में कार्बन डाइऑक्साइड बन रही है, प्रोड्यूस हो रही है, तो पाकिस्तान पे भी उसका असर देर सवेर से पड़ जाए। तो ये हमें वर्ल्ड फोरम पे इसकी बात करनी चाहिए। उसके बाद फैज भुट्टा साहब, अनफॉर्चुनेटली हमारे पास जी आवाज आ रही है सबको? आई थिंक ऑल द पार्टिसिपेंट्स आर इन अगेन। कैन समबडी कंफर्म?
जी आ रही है, आ रही है, हाँ आ रही है।
ओके, सो जस्ट ए मिनट मोर। वसीम कुरैशी साहब की किलोवाट लैब्स और WRL और बहुत सारी उनकी कंपनीज हैं जो प्रोडक्ट मैन्युफैक्चरिंग से लेके और दूसरी कमर्शियल एक्टिविटीज में इन्वॉल्व हैं। एंड वी आर रियली हैप्पी दैट एन इंजीनियर फ्रॉम लाहौर इज आल्सो एंड अदर बिग कंट्रीज। और हमें इस तरह के बहुत सारे एंटरप्रेन्योर्स चाहिए। एंटरप्रेन्योरियल स्पिरिट लोग बहुत कम हैं, तो इस तरह के लोग हमें चाहिए। और इन द एंड
क्या करें? हेलो,
so I think I have concluded. Perhaps we can
okay, Irfan sahab, and
have Mr. Nadeem Akram.
this webinar is going to conclude, and I would like to request Mr. Nadeem Ashraf, Chief Marketing Officer of Energy Update, for a vote of thanks.
Ladies and gentlemen, thank you for joining the webinar. My special thanks to our speakers, Mr. Lim Chong Boom, Mr. Wasim Qureshi, Mr. Faiz Bhutta, Ms. Mariam, Irfan Ahmed Sahab, and Mr. Mansab Khwaja. Energy Update is not only a magazine, but it serves as a very effective think tank on country's energy issues. We have a great track record on bridging between stakeholders and government decision makers, advocacy of investors in the interest of country. I would like again thanks to you people. Please keep connecting to Energy Update. It's your own platform. Thank you much.
Thank you all participants, and thank and moderated this event. He is really very supporting for us, or inshallah, will organize such events in future on renewable energy and power sector. So see you soon, inshallah. Thank you so much, and please contact me through my WhatsApp for any questions and any queries. My WhatsApp mentioned in my messaging जो है वो link. So inshallah, we'll see you soon. Thank you so much, all of speakers, participants, and Irfan Ahmad Saab and all our team. Thank you so much. Thank you.